So is the function growth or decay? So here's the deal on this one. So growth means that my b value is going to be bigger than 1. Okay? Decay is going to be less than 1. So if I type into my calculator 3 divided by 2, that's going to give me 1.5. Is 1.5 bigger than or less than 1? Bigger. So this guy is going to be growth. And the y-intercept, that means that I'm going to plug in 0 into my equation. And that's going to give me my y-intercept. So if I plug in 0 into this equation, I'm going to get 3 halves raised to the 0 power. Well, I know anything to the 0 power is going to give me 1. So my y-intercept is going to give me 1. Okay? On number 2, what's going to happen is we're looking at this b value right here. Is that bigger than or less than 1? Less than 1. So that's going to be decay. If I'm trying to figure out what the y-intercept is, I'm going to plug in 0 into my equation. So if I do that, I'm going to get 0.3 to the 0 power, which is going to give me 1. And 2 times 1 is going to give me 2. So my y-intercept is going to be 2. Do we see the process? Okay? All right, on 3, is it going to be growth or decay? And my y-intercept, if I plug in 0 into my equation, I'm going to get 1/3 times 1. Well, we know that 1/3 times 1 is going to give me, so my y-intercept is going to be 1/3. Yes. For y-intercepts, you're going to plug in 0. For x-intercepts, we're going to set it equal to 0. No. Okay? All right, on the next one, we're going to graph and label the domain and range. So when we graph this, I would highly suggest you use a graphing calculator. So what's going to happen is you're going to go into that y equals button, and you're going to type parentheses 1 divided by 2, close parentheses, second ln, because that's going to give us that e, raised to the x minus 2, close parentheses. Okay? And then what you're going to do is hit second graph, and that'll pull up a table to help you plot. So again, I'm not going to ask you on your quiz to actually graph it, but I will ask you to match the graph to the equation. So just like what you did in that matching task card, same concept. So we're going to plot this though. So 0.06, that's going to be right here. I've got 1, 0.18, 2, 0.5, 3, 1.3, 4 is going to go to 3.69. So this is going to look like that roughly. Okay, don't laugh at it. Okay? Okay, so I go into y equals. I type this equation in. And then I hit second graph, and that pulls up my table. And if I want to check and make sure that I drew it correctly, because like sometimes like I'll be drawing some funky stuff, this is what it's going to look like. Okay? Cool?
Yes.
Alright, so here's the deal. Do you see how there's nothing added on at the end of this?
Yes.
That means that we're going to have a horizontal asymptote at y equals 0. Okay? So there's going to be a horizontal asymptote. I'll teach all that in a little bit. Give me a second. At y equals 0. Okay? So for my domain for this guy is going to be from negative infinity to positive infinity. And my range is going to be from 0, but it's never going to touch 0, so we're going to put a parentheses. And then it's going to go all the way up to positive infinity. Because it doesn't touch it, but it gets really, really, really close. So like when we go into our calculator and we look at these, it goes all the way close to 0, but never actually touches it. No, we're talking about our y values. That's your x's. We don't talk about our x's except for domain. Okay? All right, so now let's look at number 5. Let's look at number 5. Wow. Okay? On number 5, we're going to plug that into our calculator. So we're going to hit y equals, and we're going to type 2 to the x plus 2. Is that what it says? Yeah? My bad. minus 5. Then you're going to hit second graph. That's going to pull up your table. Okay, so now you're going to plot these points. So you've got a point at 0, 1. You got a point at, 0, negative 1. You got a point at 1, 3. 0, negative 1, 1, 3. You got a point at 2, 11. And you also got a point at negative 2, negative 4. So when I connect these points, they're going to look like this, roughly. Sorry for that little, like, weird curve. It's like a bend. Listen, don't hate on it. Okay, do you see how there's this negative 5 out here? There's going to be a horizontal asymptote at negative 5, at y equals negative 5. Okay, that means that it's going to get really, really close, but never actually touch it. Okay, horizontal asymptote at y equals negative 5. Okay, let's talk about our domain and range. Our domain is going to be from negative infinity to positive infinity. I can plug in any x value. And my range is going to be from negative 5 to positive infinity. Okay, if I'm going to put this into my calculator, I'm going to hit that y equals button. I'm going to hit negative 3, parentheses 2, raised to the x. I would put parentheses around that x because otherwise it's going to give you something funky. Plus 1. I'm going to hit second table. That's going to pull up my table so I can graph it. So I'm going to have a point at 0, negative 2, 1, negative 5. 2, negative 11. Oh, sorry. It's not here.
Isn't that kind of like the last one?
It's kind of like it. The only difference is it's flipped, right? Okay. And where's the horizontal asymptote going to be on this one? At positive 1. So there's going to be a horizontal asymptote at y equals 1. Okay. Which means, it's going to get really, really close to 1, but never touch it. So my domain is going to be negative infinity to positive infinity. And my range is going to be from negative infinity to 1. Okay?
Wait, why negative infinity?
Because it's going down. You see this negative out front?
Yeah.
That's a reflection over the x-axis, which is what y'all just saw on those matching things, right? Okay? Alright. Alright, so here's what's going to happen. I need to graph this. So I'm going to take my graphing calculator, and I'm going to hit on. I'm going to go into that y equals button. I'm going to hit clear. And I'm going to type 1 divided by 2 in parentheses. In parentheses 3 raised to the x minus 2. Yes, I use that many parentheses because otherwise it would tell my calculator to do something different. I'm going to hit second graph. And when I do that, it's going to pull up a table. I'm going to use this table in order to help me graph. Okay? I'm never going to ask you to graph something. I am going to ask you to identify the graph based off of the equation. So I'm going to plot the point 0, 0.05. I'm going to plot the point 1, 0.16 and 2, 0.5. Going to graph the point 3, 1.5. And 4, 4.5. Okay, so my graph's going to look something like this. Okay, and the way I can check that is I can just hit the graph button, and my graph should match up with what I have drawn, which it does, roughly. Okay, my domain is going to be from negative infinity to positive infinity, because I can plug in any x value. My range, I'm going to look at my lowest y value. Well, we've got something called a horizontal asymptote at y equals 0. Okay, and the reason why I know that is because in any exponential function, whatever is added or subtracted on at the end is your horizontal asymptote. which in this case is plus 0, which like normally we don't write plus 0 out, okay? So our range is going to be from 0 to positive infinity. So this is a lot like what your quiz is going to look like. It's going to say matching, and here's all that you're going to do. You're going to say, all right, I'm going to take this first equation, I'm going to put it into my calculator. Okay, and the hardest part is actually typing it in, so I would practice that at home. When you hit graph, it's going to look like this. Well, which one does this look like? B. So on 11, it's going to be B. Okay? On 12, we're going to go in and we're going to say, all right, negative 4 raised to the x value minus 3. We're going to hit graph. And the graph's going to pop up. Which one does that look like? On number 13, we're going to type that into our calculator. You want to make sure that you use your parentheses. When you hit graph, you're going to pull up this graph. Well, this doesn't look like A, right? But does it look like any of the graphs down at the bottom of your page? Which one? E.
E.
Yes, Trace. Okay, so let's look at 13 again. So if you put it in like this, I'm going to get this graph, which the only graph that it looks like is E. Yeah. All right, let's try 14. Okay. 3 to the x plus 4 minus 3. I'm going to hit graph. And before I even graph it, I know I'm going to have a horizontal asymptote at negative 3, right? But that means that my graph is going to be F for sure, because that's a horizontal asymptote at negative 3. Okay? If I graph 15 and 16, 1 divided by 4 raised to the x plus 3. So this is going to look like A. So I assume that this one's going to be D. Okay, well, let's check it. Okay. Yeah, hit that y equals. You're going to go 3 to the x power plus 1. Oh, nope. Nope, don't like that. Okay. Hit graph. Boom. Trace, you're wrong. Okay. Yep. Okay. Questions over that quiz. You're going to have to identify the graph. Okay, so identify the graph. You're going to have to find the x-intercepts, find the domain, find the range, find the intervals of increasing and decreasing, and find the average rate of change. Okay, so basically what we did yesterday and today. Okay, so you're matching, which is the identifying your graph, x-intercepts, domain and range, increasing, decreasing, and average rate of change. Okay? Questions over that? You don't have to do number whatever it is on that review. That last one.
18?
Yeah, 17 and 18 aren't going to be on there. Okay? I want to go over logs really quick. How to graph them because it's a little funky. So if I wanted to put this into my calculator, what I would do is I would say log of x plus 5 divided by log of 2. So you know that change of base thing? That's basically how you graph. Boom, done. Okay? The exact same process that we've been doing. The only difference is now we're just putting it in a graph. Okay? These will have vertical asymptotes. Vertical asymptotes. Okay? So it's going to have a vertical asymptote at x equals -4. So with logs, you're going to have a vertical asymptote.